The Digital Construction Stack, Part 2 of 2, the GIS and BIM Connection, Section 1, Introduction. In Part 1, we showed how GIS turns the complexity of a growing East African city into something you can interrogate, model, and act on. We ended with a question. What happens when that spatial intelligence meets the building itself, when the map becomes the model? That is what this video answers. Most construction projects in East Africa still run on two-dimensional drawings, email chains, and disconnected spreadsheets. The building exists in a model that nobody updates. The GIS data sits in a folder nobody opens. The schedule lives in one person's head. BIM, Building Information Modeling, is the discipline that changes all three of those things simultaneously and connects them to each other. Let us go through exactly how. Section 2. What BIM actually is. BIM is not software. This is the most important thing to understand before we go any further. BIM is a process, a way of creating, managing, and sharing information about a building or infrastructure project across its entire life cycle, from initial concept through design, construction, and into operation and maintenance. The model is not a drawing. It is a database that has shape. Every element in the model, a wall, a beam, a pipe, a window, carries data, dimensions, material, cost, manufacturer, installation date, maintenance schedule. The geometry and the information are inseparable. Change the specification of a wall and the cost plan updates. Move a structural beam and every service that passes through it flags a conflict. This is not an animation. This is how the model actually behaves. BIM creates three fundamental shifts in how construction projects work. First, from drawing to model. Instead of flat two-dimensional representations, every element is a three-dimensional object with attributes. Changes propagate automatically through the model. Second, from siloed to shared. Architect, structural engineer, MEP consultant, and contractor all work from the same model. Conflicts are detected in the model before they become expensive problems on site. Third, from construction to life cycle. The model does not end when the building is handed over. It becomes the facility management record for the life of the building. Three shifts, one model, across the entire project life cycle. Section 3. BIM levels, 0 through 3. BIM is not a binary. You either have it or you don't. It is a maturity ladder. Understanding where a project sits on that ladder tells you what is possible, what is missing, and what the next step costs. For clients evaluating contractors, the levels are your diagnostic tool. For practitioners evaluating their own firms, the levels are your honest mirror. Let us go through each one. Level 0, no collaboration. Two-dimensional CAD drawings produced and exchanged as paper or unmanaged digital files. No shared data environment. No common file format. Every discipline works independently. Most projects in East Africa still operate here. That is not a failure. It is a starting point, and the gap between level 0 and level 2 is the gap between hoping things fit and knowing they do. Level 1, managed CAD. A mix of two-dimensional and three-dimensional CAD, a common data environment begins to exist, typically a shared drive or basic document management system. Disciplines still work in isolation, but files are managed and versioned. The model exists, but information is not yet shared between disciplines. Progress, but not yet collaboration. Level 2, collaborative BIM. This is the game changer. Each discipline produces its own three-dimensional BIM model: architecture, structure, mechanical, electrical, plumbing. These are regularly combined into a federated model. Clash detection runs automatically. Changes in one discipline's model are visible to all others. Level 3, integrated BIM, a single shared model, accessible to all stakeholders simultaneously via a cloud-based common data environment. No federated models, one live model that all disciplines read and write. Version control, access management, and audit trails built in. This is where BIM connects directly to AI, to IoT site monitoring, and to the GIS spatial intelligence from Part 1. We will come back to that connection shortly. Section 4, Bryan Geometry for D, 5D and the CD. The BIM model is three-dimensional by default, but construction projects exist in more than 3 dimensions. They exist in time and in cost. 4D BIM adds time. Link the model to the construction program, the Gantt chart, and you can simulate the build sequence visually. Watch the building go up week by week before a single foundation is poured. More importantly, identify program conflicts. 2 trades scheduled in the same space at the same time. A crane lift that cannot happen because scaffolding is still in place. In 4D BIM, these are discovered in the model, not on site, not during a dispute meeting. 5D BIM adds cost. Connect the model elements to cost data, and every design change has an immediate budget implication visible to the whole team. A wall specification change updates the quantity takeoff, updates the cost plan, and flags the impact automatically. The quantity surveyor is no longer running to catch up with the designer. They are working from the same source. Now, what holds all of this together? The common data environment, the CD. The CD is the single source of truth where all project information, models, drawings, specifications, correspondence, site records is stored, managed, and shared. It is not a folder on a server. It is a managed workflow. Documents move through defined states, work in progress, shared, published, archived with version control and audit trails at every step. Without a CD, BIM is a 3-dimensional drawing tool. With a CD, it is a project management system. Section 5 BIM in practice, 3 use cases. Let us look at what BIM actually changes on a real project. Use case 1, clash detection before construction. A structural beam and a mechanical duct occupying the same space. On a traditional project, this is discovered on site. It requires expensive rework, program delay, and a dispute about who is responsible. In a Level 2 BIM workflow, the federated model flags this clash before tender. The resolution happens in the model, not on site, not in a dispute. Industry data consistently shows clash detection pays for BIM implementation many times over on a single project. 1 coordination meeting avoided, 1 rework instruction cancelled, 1 delay prevented. The numbers compound quickly. Use case 2, facilities management handover. At project completion, the BIM model transfers to the client as the as-built record. Every asset, every pump, panel, door, fitting tagged with its manufacturer, warranty period, and maintenance schedule. The facilities team does not inherit a folder of PDFs they will never find. They inherit a live, navigable record of the building they now operate. For public sector clients in East Africa, hospitals, schools, government buildings, this is particularly significant. These buildings are expected to perform for 50 years or more. The BIM model is the instruction manual that makes that possible. Use case 3, IFC and Open BIM standards. IFC, Industry Foundation Classes, is the open file format that allows BIM models to be exchanged between different software platforms without data loss. An architect working in Revit, a structural engineer in Tekla, a contractor in ArchiCAD. Through IFC, they share a single federated model regardless of which software each team uses. For East African projects, where teams often work across different software environments with limited IT infrastructure, IFC is not a technical detail. It is the practical foundation of collaboration. Section 6, the GIS plus BIM integration. Now, the connection that makes this a series rather than 2 separate videos. In part 1, we showed what GIS knows about the land, the terrain, the flood risk zones, the infrastructure layers, the density patterns, the land use changes happening in real time from satellite imagery. BIM knows everything about the structure, the geometry, the materials, the program, the cost, the life cycle data. Separately, each is powerful. Together, they are the complete picture. There are 3 integration points where GIS intelligence feeds directly into BIM, and where BIM data returns to enrich the spatial record. First, site context into the model. GIS terrain data, utility mapping, and drainage routes feed directly into the BIM model's site setup. Accurate levels, existing services already located. Flood risk contours already embedded. The manual re-entry of survey data, which introduces errors and delays on every traditional project, is eliminated. Second, risk intelligence into design. The flood risk zones, soil condition maps, and land use change data from GIS inform structural and drainage design decisions within the BIM model before a single drawing is issued for construction. The engineer is not designing blind to the site conditions. The site conditions are inside the model. Third, asset data into the spatial city record. At handover, the BIM asset data integrates back into the GIS spatial record of the city. The building becomes part of the urban data layer. Over time, city planners can see not just where buildings are, but what they contain, how they perform, and when they need investment. This is the digital construction stack. GIS at the foundation, understanding the land. BIM at the center, managing the build. And between them, the intelligence that makes both more powerful.
This is the framework A2BY Consult brings to every project.
Section 7, East Africa Context. The major international contractors working on Ethiopian infrastructure, roads, dams, urban development are bringing BIM workflows with them. Government clients are beginning to specify BIM requirements on public projects. The question is no longer whether BIM comes to East Africa. It is whether local firms will be ready to lead it or forced to follow. The tools are accessible. Revit, ArchiCAD, and FreeCAD have student and entry licenses. IFC is an open standard. CD platforms have cloud tiers priced for emerging markets. The barrier is not technology. It is training, process, and the willingness to change how projects are managed. Closing that gap is one of A2BY Consult's core mandates, not as a distant ambition, as the work we do on actual projects with actual teams in this region. Section 8, Closing. Before we close, a word for each of you watching. If you are a student in construction, architecture, or engineering, start with the free tools. FreeCAD, QGIS, the IFC standard. Build one BIM model of one real building. That model is worth more in an interview than any certification. And the skills that come from building it, understanding how geometry carries information, how disciplines collaborate, how data flows through a project, those skills are the foundation of a career in the built environment. If you are a practitioner, a project manager, planner, or engineer on active projects, identify the one project in your current portfolio where you could pilot BIM Level 2. Not the biggest project, the one where the team is most open. That is where the change starts, not in a strategy document, in a project. And if you are a client or developer commissioning a building or infrastructure project, if BIM is not in your project brief, you are leaving value on the table. Clash detection alone typically saves more than BIM implementation costs. The as-built record reduces facilities management costs for the life of the building. Ask your project manager where you stand. That is the digital construction stack. GIS at the foundation, BIM at the center, and the intelligence that connects them. 2 videos, 1 framework, built for East Africa. This is A2BY Consult. We will see you in the next series.